Assalamu alaikum, greeting. Good morning, ladies and gentlemen. Thank you for coming. I'm very happy that you have come here today. First of all, I'd like to introduce myself. My name is Abdijalil Katal. Let me start with just a few words about myself. I'm Katal Abdijalil from Algeria. I'm from Larbit BC University. I work as associate professor for Department of Mathematics and Computer Science. Today, I'm going to talk about my work entitled by Multiscale Oriented Basic Image Features columns for handwriting digit recognition. First, we present the different state of art of works based on the recognition of handwriting digits, and the proposed features employed in our study are discussed in section 2, and the first section details the experiments conducted along with comparative analysis and discussion on the realized results. Finally, we conclude this presentation with discussion on future perspective on the subject. This work presents a novel way of extending the oriented basic image features column to multi-scale features. Moreover, this method is very efficient and robust for handwriting digit recognition, as it is less affected from variation in size, shape, and slant. The schematic diagram of the proposed method is shown in figure 1. First of all, we use the proposed multi-scale OPIF columns for extracting the feature extraction vector, and after that we using the SVM classifier for classifying the test image to 10 class. The CVL dataset has been used in the competition for recognition of handwriting digits organized in conjunction with ICTAR 2030. The interesting work proposed in this competition is reported by Katal et al. 2040, which uses different combination of statistical and structural features are extracted from the whole email or different regions from handwriting digits. In another study, Katal et al. 2016 proposed the combination of oriented basic image features, histogram, and the background concavity features without any size normalization. In this section, we first introduce new multi-scale oriented basic image features columns to address the limitation of previous OPIFs columns in terms of performance. To increase the performance of OPIFs columns descriptor, We concatenate objects image at two or more different scales to provide multi-scale objects. In addition, we do the same process to eventually produce two versions of the multi-scale objects. Then we combine two versions of the multi-scale objects to provide the multi-scale objects columns at each location. This figure shows various steps of the multi-scale objects columns histogram shell. This method is efficient and robust for handwritten digit recognition and is carried in two steps. First, we concatenate objects image for scale parameters at two or more scales to provide multi-scale objects. Second, the two variation multi-scale objects are crossed to form columns at each location. Finally, the occurrence of different patterns are collected into histogram to provide the vector feature vector. For the classification task, we selected the support vector machines SVM as a classifier. The extracted features from multi-scale objects columns are used to train our one against all based multi-scale multi-class SVM strategies for 10 digits class. Two important parameters required for training the SVM include the soft margin parameters and the radial basic function kernel parameters. In the experimentations and results section, we carried out a series of experiments to evaluate the effectiveness of the proposed system for handwritten digit recognition on CBL dataset. First of all, handwritten digits are converted to grayscale image. Next, the proposed features are extracted without any size normalization. The database comprised 7,000 handwritten digits were provided as training set and validation set, and 21,780 as used for testing. The CBL database contained a very challenge of variation in size, the problems of the shape, the writer style issue, and our experiments aimed to study the effectiveness of the proposed system used the texture based on content based on multi-scale objects column. The proposed features and the classical objects columns features are generated using two parameters, the scale parameter sigma and the parameter epsilon. We can note that the best object columns shame the best recognition using two different scales of sigma equal 8 and sigma equal 2, while epsilon equal 0.001. It can be seen from the previous figure and the following figure that the proposed multi-scale OPIFS column outperforms the OPIFS column. This is due to the cross of the best both multi-scale OPIFS images. Therefore, the multi-scale OPIFS columns with sigma equal 1 and sigma equal 2 from the first multi-scale OPIFS image and sigma equal 4 and equal 8 from the second multi-scale OPIFS do better than over multi-scale OPIFS columns configurations. In order to improve the system performance, we evaluated the multi-scale OPIFS columns using the best configurations from different uniform rectangular blocks. The following table summarizes the recall of combinations, the extraction features from different blocks. Highest recall of 9420 is achieved when the proposed feature extracted from 2 blocks, making a few vector of dimension 1550. As shown in the following table, the combined features are used to enhance the performance. The maximum value on the recall and precision produced by combinations between F1, F3 and F6, which is extracted from the 2-1 blocks and 3-1 blocks as well as from whole image, outperforms all other component features reporting recall and precision of 95.81% and 95.84% respectively. Likewise, we evaluate the proposed system for each disease class distinctly to find the difficult class from the viewpoint of recognition. Generally, the recall values are fairly consistent across different classes. Relatively low recall is reached on some digits like 3 and 9. Furthermore, it should be noted that some pairs like 3 and 8, 9 and 8, and 7 and 2 present relatively more difficult discrimination problem due to the low difference between classes. It can be seen from the following table that our system achieves second highest precision of 95.84 according to the competition protocol. It is worth mentioning here that the proposed system does not require any size normalization. It was also observed that in some cases our proposed system could not produce desired classification results. For instance, some handwritten digits found to have homogeneous vision comparing to other of different class. In conclusion, this work presented an effective system for isolated handwritten digit recognition that exploits the multi-scale or PIPS columns as features. Moreover, the proposed feature is very efficient for handwritten digit recognition, which is robust against size, shape, and length variation. The first results obtained are encouraging, with weak detection error.